Engineering materials. We're team 14. My name is David, this is Hani, and this is Mena. For presentation, we're going to start with a problem statement, and we're going to talk about types of materials. Then we're going to get into 3D printing, and then material standards, and then global aspects of such standards. Then we're going to talk about future materials research. The selection of a material for design is one of the most important decisions an engineer is required to make. The engineer must be familiarized with the latest in advancements in material science and the standards that govern proper usage of such materials. The proper selection leads to a better overall end product.
Okay, what is material science and engineering? We're going to take a look at the structure and properties of the materials, and then we're going to process it in order to get the best performance. We're going to divide the materials in 4 different types. You have metals. Metals have 3 different types. Ferrous, which contains irons. Non-ferrous metals, they don't contain any irons. And alloys, which contains several elemental metals. Then we're going to take a look at the structure of the metals, because the properties of the metals come from the structure of it. We have C electrons going around the nucleuses. That's where we have heat and electric conductivity, and also malleability of the metals coming from that structure. The second types of the materials are ceramics. Ceramics are generally taught as inorganic and non-metallic solids with a range of useful properties, including very high hardness and strength, extremely high melting points, and good electrical and thermal insulation. The best known ceramics are pottery, glass, brick, porcelain, and cement. The third type of materials are polymers. Polymers, which are long chain of molecules made of many repeating units called monomers. Polymers could be found in the nature, or they could be made in the lab. Basically, whatever made of plastics are polymers. Then we're going to talk about the structure of the polymers. In the cross-linked polymers, the units are linked with covalent bonds, which form a giant 3-dimensional structure, which are strong and tough, and the movement of the molecules are limited. The polymers with the linear change molecule are soluble and thermoplastic, whereas the 3-dimensional polymers are not soluble in the regular solvents. The fourth type of material that we're going to cover are composites. A composite is a structural material that consists of 2 or more combined elements in microscopic level, which they are not soluble in each other. One part is called reinforcing phase, and the other part is called matrix. The reinforcing phase material may be in the form of fibers or flakes. The matrix phase materials are generally continuous, like graphite fibers. Then we're going to cover the structure of the composites. The physical properties of composite materials are generally not isotropic in nature, but rather are typically anisotropic. For example, the stiffness of a composite panel will often depend upon the orientation of the applied forces and moments. Panel stiffness is also dependent on the design of the panel. The fiber reinforcement and matrix used to build the panels gonna make the structure of the composites.
3D printing. 3D printing already changed the way we produce objects, from tools and toys to clothes and even body parts. The first 3D printer was invented in 1983 by Chuck Hulse. It was mainly used for industrial prototyping. 3D printing is a part of a process called additive manufacturing, where an object is created by adding layer on layers. Additive manufacturing allows the designer to create complex parts at a fraction of a cost and time compared to other traditional techniques like forging and casting. The material available for 3D printing have come a long way since the early use of the technology. There is now a wide variety of different material types that are supplied in different forms, as filament, pellet, and resins, and powders. Here is a table of some of the most used materials in 3D printing. Some of those materials are plastic, steel, gold, glass, wax, brass, bronze, and so on. Plastic is the most widely used material in 3D printing. It's most common use in prototyping and among home 3D printer owners. Metal is also one of the materials used in 3D printing. Some of the most used metal are steel, stainless steel, and gold. 3D printing food is becoming very popular, with the chocolate being the most common and desirable. Local Motor has its first 3D printed car with a top speed of 40 miles per hour. The company hopes to make the car available for around $17,000. The time took them to create the car was 44 hours. The biggest 3D printer is the one owned by a Chinese company called Larsson. The best part about Larsson technology is that it uses recycled cement from construction waste to build houses. The company was able to build 10 houses in one day, with each housing cost $5,000. In the medical field, doctors are testing biomaterial for a host of medical applications. Using a patient cell, doctors can create small 3D body parts like ears and noses. Some surgeons have even printed 3D organs for transplants.
A standard is a set of specifications for parts, materials, or processes intended to achieve a specified quality. There are a variety of organizations that have established specifications for standards. The American Society of Testing and Materials is a globally recognized leader in the development of voluntary consensus standards. Material properties are most reliably measured by standardized testing. The ASTM has documented many material testings. The American National Standards Institute establishes a consensus procedures that are the basis for development of standards. They do not make standards, they accredit organizations who develop standards. The Society of Automotive Engineers is a global association made up of engineers, educators, and businesses. SAE technical committees writes more aerospace and automotive engineering standards than any other organization. SAE covers mechanical and physical properties of materials used in these industries. Standards organizations such as ASTM develop their standards to be compatible in the global market. For businesses ranging from Fortune 500 leaders to emerging startups, globally oriented standards help level the playing field. 3D printing is already having an effect on the way that products are manufactured. Consumers are able to have their own line of production, which can allow businesses to bypass logistics such as manufacturing and shipping. The shift to production could reduce the imbalance between export and import countries. A recent advancement in materials engineering is the creation of a single atom layer of sheets of graphite called graphene. The honeycomb lattice of carbon-to-carbon bonds is flawless, light as shown. Conductive inks, known as electric ink, would enable the integration of electrical circuits. Electric ink could lead to regular people printing their own circuit boards, solar cells, and other electronics.